Hello everyone, this is Dr. Chaitanya Krishna. Welcome to Cynohub. In this video, we are going to explain about the polarization. Here, what are the different types of the polarization? How the elliptical polarization should be more efficient. Now, here before going to all these topics, now what is the polarization? Here, polarization means the movement of electromagnetic wave. The movement of electromagnetic wave in desired direction, that is called as a polarization. This polarization, whatever the electromagnetic field is there, in that electromagnetic field, electric field and magnetic field, in which directions and which dimensions and which phase they were moved, they are going to decide in the polarization. Polarization is simple, is the movement. Polarization is simple, is the movement. Polarization definition is simple way is the movement of electromagnetic wave. Movement of electromagnetic waves that have the electric field should be there, and as well as magnetic field also should be there. Electric field and magnetic field should be a perpendicular to each other. Magnetic field, electric field and magnetic field should be a perpendicular to each other. Then only the desired direction should be there. Then only the desired direction, the wave should be transmitted. Wave should be transmitted. That means wave should be polarized. Wave should be polarized. That here in this polarization we have the mainly three types of polarization is there. Three types of the polarization. One is the linear polarization, circular polarization and elliptical polarization. Means whatever the resultant wave should be there in the linearly or where along the along the line the wave should be going to propagate. Where and how the wave should be propagated depends upon this one, how the wave should be polarized. Depends upon this one, we have the three types of polarizations are there. One is the linear polarization, circular polarization, elliptical polarization. In the name itself, it states that the polarized wave in the linearly, and this should be the circularly, and this should be the elliptical. Whatever the wave should be transmitted along the axis should be a linear, should be a circular and should be a elliptical. But in these three, some differences should be there. How the difference? Here this linear polarization, along the axis, whatever the wave transmitted through which axis, that should be a, in that axis, in that direction should be a linear. In the direction should be a linear. That polarization we can call as a linear polarization. Whatever the electric field and magnetic field is there along the straight line should be a linear. Along the straight line should be a linear. That should be a linear. Then the polarization we can call as a linear polarization. Whatever the electric field should be a linear to the axis. That the polarization we can call as a linear polarization. After that, the next polarization is the circular polarization. In this circular polarization, whatever the electromagnetic field should be the, what is the electric field and magnetic field should be a perpendicular to each other. At this one, whatever the electric field is there, in that electric field will be oscillated along the one plane only, along the whatever the direction is there, along the one plane only. Then that is the linear polarization. Whenever the circular polarization will come, whatever the E and H should be a perpendicular to each other. E and H should be a perpendicular to each other. The amplitude should also, electric field and magnetic field amplitudes also equal with 90 degrees phase shift. Means in the circular polarization, the magnitudes of the electric field as well as magnetic field should be the 90 degrees phase with equal amplitudes. Then the polarization we can call as a circular polarization. Whatever the electric field and magnetic field two perpendicular are there, these two perpendicular waves have the same magnitude with 90 degrees phase shift. phase shift should be there along the plane. That polarization we can call as a circular polarization. Next one is the elliptical polarization. In this elliptical polarization, electric field and magnetic field should be should be a perpendicular to each other, but amplitude should be a unequal amplitude. That's why the wave should be polarized in elliptical direction. The magnitude high and low should be there. Elliptical direction, the wave should be polarized. In the circular polarization, when the magnitudes are equal, that's why it forms a circle. Whenever the unequal magnitude, this should be a elliptical side. Wherever in which direction or in which movement we have to find the polarization, the very important is the elliptical polarization. In this elliptical polarization, the magnitude should be a unequal magnitude. That is not equal, unequal magnitudes of E and H components with 90 degrees phase shift. That's why in this one, the elliptical polarization should be a very important. Whenever the electrical polarization is there, we can apply the condition, then we will get as a circular polarization as well as linear polarization. Here the magnitudes are unequal. Whenever the equal magnitudes are there, there should be a circular polarization. Whenever the magnitudes should be a linearly increasing with electric field means, then that should be a linear polarization. This all about the polarization of electromagnetic waves in electromagnetic. Okay, right. Thank you.